Class example 4.32. The graph on the right has integer values for any asymptotes or y-intercept. Determine an equation in the form y is equal to a over x minus h plus k. So first thing I want to point to is the fact that it says integer values for any asymptotes or y-intercepts. It's really just telling you that if it looks like our asymptote there is at -1, it actually is at -1. Okay. So first off, let's start by identifying our h and our k values. Those are going to be the probably easiest to find. So what we want to do is compare this to our basic graph of y is equal to 1 over x. Now let's take a look. So our h is really going to be our horizontal translation, and our k is going to be our vertical translation. So you can see from the graph that our vertical asymptote is now at x is equal to -1, which means that we had a horizontal translation of 1 unit left, which means h is -1. And our horizontal asymptote is at y is equal to 3, which means we've had a vertical translation of 3 units up. So k is equal to 3. So fill those numbers in. Now, we're pretty much there. We just don't know what a is. Well, it would sure be nice if we could throw in some numbers for x and y and then solve for a. So that's what we'll do. We'll use any point on the graph to solve for a. Now, y-intercepts are typically nice if you can see them, but any point would work. So let's throw in 0 for x and 1 for y. And then solve for a. So a is equal to -2. Next, you should verify your equation using your graphing calculator. So just graph what you just found. Make sure it's written in as shown. All right, part B. Use an algebraic process to convert to the form y is equal to f of x over g of x, where f of x and g of x are linear functions. So don't panic about the f of x and the g of x part. That's really just saying that we're going to have some expression in the numerator over some expression in the denominator with nothing else hanging off the end like a +3, like we had here. So let's start with the expression that we know. And we really just need to incorporate this +3 into one rational expression. So we need to write that 3 as over a denominator of x plus 1. So the way we can do that is by multiplying by x plus 1 over x plus 1. And then expand the 3 in. And now that we have both fractions written over the same denominator, we can just write them over a common denominator of x plus 1. Now the brackets here were kind of redundant because we're adding, so they didn't really matter at all. If they were subtracting, we'd have to be a little bit more careful, but since we're adding, those brackets can just disappear. And then there's our form. Y is equal to 3x plus 1 over x plus 1, where we can consider 3x plus 1 f of x and x plus 1 g of x. Now, as before, we should graph this to make sure that it actually is the same. And you can see if we graph both versions of this equation, it is in fact the same function.